So welcome everyone to the January Quantum Marketplace webinar. It's great to see so many familiar names and faces, and looking forward to a fantastic set of presentations today and a discussion around a really important topic, test and measurement. This is an area of critical need for the quantum ecosystem and the quantum industry going forward. It's come up over and over, including in some of our recent workshops on control and readout electronics, on single photon sources and detectors. And so I'm excited to hear more from the QED-C members who are in this space, and looking forward very much to learning what they're offering and where they see the field going, and perhaps hearing also about what the gaps are a little bit and how we can address those through the QED-C. So with that, I'll turn it over to Mark Wippich to get things started.
Great, thank you, Celia. So let's get right into it. Okay, so just a quick comment on logistics and format. Everyone's muted except for the speakers. If you have a question, please post it in the chat window, and if we have time, we'll get to it. Also, the webinar will be recorded and posted on YouTube in the future. Okay, so the agenda for today, just a quick update on the quantum marketplace. Again, we're going to be just touching briefly on some of the trends and on an overview of the test and measurement for quantum market, and then we're going to be getting into the lineup. And then we're going to have a roundtable discussion, and then a quick snapshot on some upcoming webinars. Okay, so for people who haven't seen, QED-C has developed a quantum marketplace page on the website. All the prior companies that have presented have a little video icon next to them, so you can click on these and you can see the videos. You can also, when you click on the company, most of the companies have detailed description of what they offer the marketplace. It's very useful. If you just want to find it quickly, just type quantummarketplace.org. It'll redirect you right to that. And then also, we do have a public YouTube channel. We now have 66 subscribers, so it's starting to grow. Our goal is to get it over 100. So if you haven't already, please hit the subscribe button. Once we get over 100, we will get what we're told is we'll get a more elegant YouTube address. So anyway, so let's go into just a quick snapshot of some overview and trends. So various quantum technologies continue to grow and evolve at a very fast pace. And so as the technologies and the products and the hardware and the software progress, it's also very important that metrology keeps up with that. So it's driving a need for better and ever evolving metrology. So with that, we're gonna get into this lineup here. So we've got, we actually have Jens Kuchenmeister from Thorlabs, and we have Jack from FormFactor, and we have Philip from Keysight, and we have Will Madsen from Rigetti. So with that, Jens, can you share your slides?
So hello, everyone. I represent Thorlabs, a photonics manufacturer, and we manufacture and develop all the items that you see here. So we have mechanics, optics, light sources, light detection and analysis, motion control. I could go on all the way up to complex systems such as microscopes. We're headquartered in New Jersey, and the team that developed the item that I'm going to show you today is located in our Munich facility. So today's topic is quantum test and measurement, right? And things tend to get ugly pretty soon, as you see here on the table. So we manufacture all of this, but when we talk about quantum test and measurement, the expectations get higher. So for example, you might need a very low noise laser source. You might need optics that are more stable with regards to thermal drift. And for example, you might need a special detector. And that's what I'm going to talk to you today about. It's our new single photon detector, Spdma. It is a Geiger mode avalanche photodiode, which means that even a single photon already gives you an output pulse. It has a really small footprint. So to the best of my knowledge, it's the smallest that you can buy out there. And we achieve that by two things. First of all, a highly efficient tech driver. We're strongly vertically integrated at Thorlabs. So we actually do these ourselves. This comes in a small SMT package. You can purchase these in high volumes. And these are highly efficient, meaning very low heat dissipation. And secondly, the entire thermal design of the detector is really well done, so we don't even need cooling fins. One nice aspect of it is that you can change the overvoltage, meaning you can tailor it to your experiment, either minimize dark count rate or maximize the photon detection efficiency. And lastly, it has a very large active area of 500 microns, which is especially suited for free space applications, but you can easily fiber couple it through those mechanical ports here. So the takeaway being, it's a great detector in a really small package. Now we tested this detector in real life situations, so we were sure that it's up to par. And one of the beta testers was the University of Hanover, where they did a single photon interferometry experiment, and I'm going to walk you through it. So at the bottom here, there's a blue laser that goes all the way up to a non-linear BBO crystal where a pair of photons is generated. They travel to the detectors up here. A beam splitter guides parts of the light down towards a Michelson interferometer, at the output of which there's the third detector. Now, as you probably know, in a classical interferometer, when you change the length of one arm, the output pattern will be an oscillatory behavior. And the same is actually true for single photons. So even single photons show interference. This is what they demonstrated here. And again, let me point out the small footprint. So when space is at a premium, this is a really great detector. So the takeaway being here, it's a field-proven detector, plug and play. You can just put it in your experiment, hook it up to your electronics, and you will see the output pulses. Finally, a little output. So there's more of these detectors to come. The group that develops these is in the second floor of our new Munich facility here. They're developing more of these. And it's probably interesting for you to know that we actually ship these same day. So both from our facility in Munich as well as our headquarters in New Jersey, they ship the same day. We keep these detectors and everything else that we have on stock at all time. Finally, let us know if you have any feedback, product ideas. We're really all ears. If you're looking to implement a specific application, or if you're looking at an OEM project, we're really here to help. Just get in touch and drop us an email at europe@thorlabs.com. Thank you very much. You're still muted, Mark.
Yeah, can you go back to slide 4? Great.
Sure.
So it's great to see Thorlabs has an off-the-shelf single photon detector that ships the same day. How about the rest of this setup? Can someone just buy this whole setup and build their metrology in lab without having to go to multiple vendors?
It's funny that you should ask this, because we do have a line of educational kits. For example, an atomic force microscope, very cheap and versatile, a quantum cryptography setup, for example. So if you want to look at an actual protocol for quantum cryptography, you can buy this. And we're currently thinking about adding this one here as well. So you could really buy this as a one kit option with a proper manual how to set it up. So this is something that we're thinking about. If anyone's interested, again, please drop me an email.
Great, great. Thank you, Jens. Okay, Jack from FormFactor.
All right. How are we doing on the slides there?
Doing great. Doing great.
All right. So my name is Jack DeGrave. I'm a business development scientist with FormFactor, and today I'll be talking a little bit about our position in the quantum marketplace, specifically around cryogenic test and measurement. So a quick introduction to FormFactor. FormFactor is a publicly traded company. We've been so since about 1993. We're about 2,200 people with worldwide offices. And we do cryogenic test and measurement, and we do systems and probe cards and everything else associated with test and measurement at cryogenic temperatures. Right now, we span the temperature range from 300 Kelvin down to about 50 millikelvin. So today I'll be focusing on our new test service business. So we serve a variety of different qubit regimes. So we do superconducting devices at 4K and 50 millikelvin, CMOS or control chips, as well as components at 4 Kelvin, 77 Kelvin and below, and then also photonic devices. So one of the things we've noticed with the quantum marketplace is that really cryogenic test equipment is something that's very expensive. It comes with a high capital cost and also really long lead times. And this has really limited the access for quantum developers to sub 4 Kelvin and 2 millikelvin systems, which has resulted in slowed development cycles and really the inability of certain component suppliers to qualify their devices at those operating temperatures. So our solution to this is to provide test as a service. So this is our new cryogenic test and measurement as a service platform. Basically, you can engage with us immediately. We have systems available and it provides immediate access to quantum computing developers. And developers are using this service to reduce R&D risk, learn design for tests. You get access to probe cards and different probe head technology to interface with your DUT. And we're really trying to eliminate that high capital cost barrier to working with cryogenic equipment. And a lot of people are also using this to prepare to scale, trying to understand what you can do at the wafer level, what are the types of measurements and data that you can get to inform your program and improve your fabrication process. So right now we have two different systems available. So the first one is a 50 millikelvin ADR cryostat. This is for chip and component testing. It can be paired with a probe socket, so we can easily interface with the device. It's customized to your particular pad layout. Then we also have our wafer testing system. So this is right now for 200 millimeter wafers. It's magnetically shielded, so it's well suited to measuring superconducting qubits. And as part of this kind of initial launch of the program, we're offering 3 free test days on the Wafer Prober associated with a probing package. So what does test service engagement look like? Basically, what happens is when you engage with us, you're going to be working with our application specialists and measurement experts. So it starts with your idea. Maybe you have an idea of something you want to measure, whether it's at millikelvin or 4 Kelvin to inform a fabrication process. Then once you're working with our application experts, we're going to finalize a test plan and define how we're going to interface with that device. So a variety of probing solutions are available, whether it's full-scale wafer probe cards or probe sockets for chip level testing. Once we have that plan in place, we're set up and ready to go. So we'll test and measure chips and wafers. We have a variety of test equipment available to our users, which includes things like VNAs, basic source measurement equipment. Then once we have a result, we'll analyze and discuss the data with you and feed that back into your program, and we can iterate on the test procedure. So when it comes to the Wafer Prober, we're seeing a variety of use cases. So a lot of this is statistical process control for scaling. So measuring on wafer allows you to get that inline measurement and acquire data so that you can inform your fabrication process and iterate on that. We've done niobium resonators doing S11 and S21 measurements. JJ resistance, we have a paper out with MIT on the archive right now, so you can take a look at the link down below. And then some people are also interested in informing how you might get room temperature diagnostics on qubits and inform their low temperature performance. And this is really the idea of building machine learning models. And in order to do that, you need very high volumes of data. So the Wafer Prober is very well set up to do this type of thing. When it comes to the 50 millikelvin test service, qubit and resonator pre-characterization is the main goal. We have a solution brochure up on the website if you want to read more about that. It's also being used for process control and materials development. Vendors can use this system for component qualification. So you can install a component, see how it performs at millikelvin temperatures, and then provide some sort of performance validation to your customers. So with that being said, we're looking for quantum developers and component suppliers to engage with this new cryogenic test service. So please bring your idea to us and we're ready to discuss. Thank you.
Great, thanks, Jack. So in terms of your test service and your 3 days of free test, What's the typical lead time from start to finish for one of these cryogenic test services?
Yeah, so the lead time really comes down to the probing solution, right? So these systems we currently have available and we can engage right away. And it's really a question of if it's at the chip scale, do we need a custom probe head or a custom device interface there? And some things, we have in stock. So some things are, maybe 2 to 3 weeks out. And then, others, like a full scale wafer probe card might be a little bit longer than that. So again, the system's immediately available, and it, lead time's really dependent upon that probing solution or the device interface solution.
Great. Thanks, Jack. So Phil from Keysight, you're up.
Okay, thanks, Mark. My name is Philip Krans. I'm one of the business developers of the Quantum Engineering Solutions team at Keysight Technologies. And today I will tell you a bit about the Labber, which is our premier software for controlling quantum experiments. The Quantum Engineering Solutions team, so we are actually a part of, as you know, Keysight is a large company, about 15,000 employees. We are about 40 to 50 people within Keysight focusing on only quantum. And you can see the locations here. And what I wanted to point out here is that we have a few different acquisitions that we did within quantum that's really been the seed for the team to grow. And the focus today would be about the Labber, which was a spin out of MIT. So when you think about Keysight, you might think about test and measurement equipment for various applications. And within quantum, we noticed that there's a big gap between the actual instruments that you use and the end applications that you have. And this is exactly what the software suite of Labber and PathWave FPGA are about in the middle here. So the idea is really to enable small scale experiments up all the way to large scale scaling quantum systems and do that in a way that's easy for the end user. What every lab needs is an easy lab infrastructure that everyone can use. And this is a lot of reinventing of wheels around the world, that every lab needs to build lab drivers to be able to communicate with instruments. You need to run the experiments efficiently, and you need to analyze the data. And for industries, that often leads to launching a product or an application, or for academic research labs, you publish papers. So what Labber allows our users to do is that we have an infrastructure for this, so that individual labs doesn't have to spend a lot of time developing the infrastructure before they can run experiments. So this is more of a turnkey approach, where we have an instrument server, a measurement editor, and a log browser. So the way this looks like is the following. So the starting point is to connect all the instruments in the lab to the instrument server. And these instruments can be both real instruments, physical instruments, as well as virtual instruments. And these virtual instruments are really pieces of code that help the experiment in some way. And for those of you who are measuring on quantum systems, you know that you need to create pulses, you need to be able to demodulate data, and that there's a lot of functions in between the actual physical instruments that you need. So this is all taken care of here. And then you have the measurement editor, which is really where the cockpit of where you run the experiments from. And this is also very easy to use, that I will show you in a bit. And finally, the data ends up in a log browser. And this is really to organize the data and to make sure that everyone in the team knows what's going on and how the data was taken. So this is a great tool for not only analyzing data, but also to keep continuity in a team when you get new team members and when other ones leave. Finally, we have a Python API that can control all of this programmatically, so that you don't have to use the graphical user interfaces if you don't want to. So the instrument server is the starting point. This is really a list of instruments in the server, and the server handles communication across a lot of different interfaces. And it also does this in parallel, so that the communication between individual instruments is not slowing down the overall performance. If we take a look at one specific driver here, we have the multi-qubit pulse generator. So this is an example of a virtual driver that is used for qubit measurements to shape pulses. Next, when we enter into an experiment, what we do is that we add the instruments from the server, and we then import the instruments that we actually use for a specific measurement. And then we drag and drop settings from left to right. So this is a way to set up the scenario or to configure the measurement as you want. And then you set a log channel. So for instance, a digitizer channel or some oscilloscope where the data will end up. And then you give this file a name and you click start. And then you can follow the progress of the measurement in an easy way. So as you can see, this is a very fast way to configure a measurement and to run it. So it's very good for beginners or for people that don't have a lot of time. And that's a general trend in this business. Finally, we have the log browser. And this is where all the measurements, not only the data, but also the configurations end up. And in here, you can immediately analyze the data as it flows in, and you can do a lot of operations in here and export plots for logbooks or for even for publications. So if you want to know more about Lab, or if you want to work with us, or if you have an application that you feel would be suitable for Labber, then don't hesitate to reach out to me. And you have an email address, and you can also find more information on our website about Labber. Thank you for your attention.
Great, thank you, Philip. Can you go back to slide 5?
Yeah, sure.
So it's great to see Keysight being not only just Keysight, but you can connect to other companies' test equipment?
Yes, that is correct. We recognize that every lab has a mix of vendors in the lab. So we feel that it's important from the end user perspective that we keep this open so that they are not locked into a corner of choosing vendors only to use it in the lab.
That's really great, especially with how fast the pace of quantum development is happening, right? So that's fantastic. Also, I know it isn't highlighted as much here, but I do want you to comment on, how you see FPGAs changing the game, so to speak. You care to comment on that?
Yes, of course. And this is actually one thing that, as Mark mentioned, this is not shown on this slide. This is a very high level flow of just how a workflow in the lab works. But if you look at advanced instruments such as the PXI instruments you have on this slide with an AWG, arbitrary waveform generator, and a digitizer, those instruments are very advanced in the sense that they carry FPGAs, which are lower level in the terms of programming. But what we have done with Labber is really to integrate the lower level functionality and bring that up to the Labber level so that our users can use advanced features without having to know how to program an FPGA.
It's also a lot faster than using a PXI backplane, right?
Yes, and it's very suitable for some tasks, in particular to speed up quantum applications. FPGAs are really key to do that.
Yeah, great. Thank you. Will from Rigetti.
All right. 1 second. Okay, hello everybody. I'm Will from Rigetti. Great to see everyone online. Today I want to talk about our code standard device, or coherent standard device. So at Rigetti, we are a full stack quantum computing company focusing on superconducting qubits. We operate our own quantum captive foundry where we make qubits for ourselves, but we also have opened up access so that other researchers or any small businesses in the field, if they want to experiment and send arbitrary designs our way, we're happy to fabricate those and see what kind of results we get. But in our effort to scale up our own quantum computers, we found that in this complex system, it's really tough to get reliable, fully tested RF components and everything else that's going on the inside of the fridge. And that is mostly held up by the bottleneck of fridge space and the ability and access to have a fully validated systems integration test with qubits in the loop. So in our interest to allow folks out there to innovate across the entire stack and the entire cryo-RF chain, we are introducing a coherent standard device where we are going to have pre-characterized qubits available for anyone to put in their own fridge, and then they are able to measure those qubits, see how the results stack up to the data set that we're going to publish to them, see if there's differences within their signal chain, and they can use new components, any advancements, however they want to, whatever they're working on, whether it's amplifiers, new attenuation schemes, some other way to condition the signal better. You can test them against actual qubits. Additionally, if anyone is standing up their DIL fridge for the first time, we understand how it can be like a needle in a haystack when trying to figure out what's going wrong if you're not getting the measurements exactly as you had anticipated. So with a coherent standard device, you could take the fab variables out of the picture there. So we can standardize our fab, and then you just have to worry about the innards of the fridge and what measurements you're getting. So here is a picture of our co-standard device. All of this is offered within the context of Rigetti's Foundry Services MSA. So not only are we offering custom designs that I mentioned, but you can just get standardized qubits off the shelf to put into your fridge to validate your setup or to test further with any improvements that you're making across the stack. We've found that when you want to test the reliability of your components and to ensure that there's not any way that they're introducing extra noise into your system, that it's really best to validate that setup with qubits in the loop. There's only so far that room temperature and benchtop testing can get you. So what we have here is a 5mm by 5mm device prepackaged with SMA connections. It has 2 bare resonators, 3 tunable qubits, and 3 fixed qubits. So you can look at the parity differences between the qubit relaxation and dephasing times. And that's going to come with a data package that's letting you know what frequencies are these qubits at, what frequencies are the resonators at, so you don't have to spend a ton of time sweeping for those, as well as what were the coherence times that we measured in-house. Now, these are analog devices. You're going to expect some differences in your own setup. However, this will give you a great idea of how your setup is operating and whether any new components that you're introducing to the signal chain is helping or hurting end qubit performance. So here's a picture here of our Rigetti data center, just showing that we operate a bunch of different fridges with a bunch of different devices, which means we need tons of cryo-RF componentry and electronics to ensure that we are actually getting the QPU performance for the end algorithms that we're trying to run. As with our Foundry services, where we see us opening the capacity so that researchers can get farther and further the field, we understand that innovation is truly needed across the stack. We're projecting that qubit counts are only going to grow exponentially over the next couple of years. That also means that the signals coming off the chip and that have to fit in the fridge and be conditioned properly and not add extra noise, and however you're going to go multiplexing all those things, that all is going to have to work, and we need to keep innovating. So it can't just be Rigetti or one entity that's going to be doing that. So by opening up test capabilities and by allowing for other users to do integrated systems testing within their own facilities is really going to take the entire field further and spur advancement here. So we're interested to hear from just about anyone in the entire quantum ecosystem. If you're operating a fridge, if you want to get your hands on pre-characterized qubits, if you want to try to design your own devices, your own superconducting devices to fab, we'd love to hear from you. And it's great to see that so many different entities are trying to address this bottleneck of test and measurement support, and allowing vendors across the country access to cryo testing is only going to help everyone here. So thanks.
Great. Thanks, Will. So can you comment on, your co-standard? Can you go back a few slides to your co-standard? You talked about a lot of different things here. This is really great. What do you see as the biggest benefit to this co-standard, and what are you looking for from the ecosystem?
Yeah, As I was trying to state, so one of the biggest bottlenecks is if you're a component manufacturer, and I know Jack touched on this as well, it's really difficult to get fridge time, and then it's almost impossible to get a full system up and running. You'd have to buy the fridge or find access to a fridge, and then you'd have to get your hands on a qubit device that you might have to fabricate yourself, because we don't know of any others that are commercial off the shelf available right now. So by standardizing for any fab variables there and publishing you a data sheet of the coherence times that we were able to measure, you are now able to do system integration tests to validate any new components that you want to introduce into the signal chain. And you can make a qualified statement on whether that makes qubit performance better or worse. And we think that will be immensely helpful, so that there's not as much co-development that needs to happen with every single time a vendor wants to introduce a new component into someone's some system integrator's specific fridge stack. This will allow for the standardization of components going forward in superconducting quantum systems.
And just so for clarity, because we may have some people on this webinar that are not familiar with superconducting quantum computing and know what the nomenclature of fridge is. By fridge, you mean dilution refrigerator. Can you mention the scarcity and the difficulty of these things just for 30 seconds to help people?
Yeah, absolutely. Without market sizing numbers in front of me, the estimate is probably on the order of 500 to maybe 700 dilution refrigerators in America total. I don't know what the worldwide number then would be, but extrapolate out somewhere from there. But these dilution refrigerators, you're operating your QPU in there like as a quantum computer, but you also need to do your full systems validations in there. So there's a push and pull constantly between whether you're using this dilution refrigerator for development or for actually operating these systems over a long term. And that was longer than 30 seconds. But one last thing is these dilution refrigerators, they get down all the way to 10 millikelvin base temperatures. And that's really critical for maintaining the noise environment around our superconducting qubits.
Great, thank you, Will. That was great explanation. Okay, I'm going to take the presentation back over here. Let's see. Okay, so fixed your name there, Jens. Okay, so let's go into some questions in the panel discussion here for the speakers. So looking at the various presentations and how this is addressing test and measurement for quantum. So this is a fast-moving market, especially in certain areas. Why should a customer use next generation metrology hardware and software from leading providers such as yourselves rather than develop it themselves? I think we should start with you, Philip.
Sure. Thanks. That's a very, very good question. And I have seen a very big change in the mindset of the field the last 5 to 10 years, in the sense of 10 years ago, everyone wanted to do everything themselves. And when it comes to lab control software, that's definitely true. But as the experiments get more advanced and as the pace of the field gets more rapid, we feel that this should happen in industry, that we have a controlled way of growing the complexity without introducing that complexity to the customers. And that's one thing that we hear a lot, that there's a need for easy to use solutions to run advanced experiments.
Great. Jack, why don't you go next on that if you have something?
Yeah, I would say that, I've seen a similar trend in cryogenics over the past decade. And, I think the great thing that happened, at least from the cryogenics side, was you're seeing larger corporations like FormFactor bring their decades of experience in semiconductor technology and bringing that into the cryogenics realm for the quantum marketplace. So we're able to leverage a lot of the know-how and experience that's been developed at room temperature. So for instance, when it comes to photonics or high throughput wafer probing, we're able to take a lot of that know-how and translate it to low temperature. So, that's been hugely beneficial. And then I would say the other thing that has been great is there's a lot of behind the scenes collaboration between, a lot of vendors and companies in this space. and they're really coming together to figure out how to bring their tools together, right? So, for instance, one of the things that we've done is, we've written a driver for some of our cryostats for Labber, so that we're able to kind of plug that into the Labber software and make sure that a user is able to set up an automated measurement routine using that. So, yep.
Great. Thanks, Jack. So Will from Rigetti, any comment?
No, I mean, that all sounds great. And I think one of the biggest things with superconducting quantum specifically is just how many different fields of expertise are required to make your own metrology hardware or integrated setup. And I think that customers should be looking to, focus on what they have expertise in or what they're able to actually create in-house. And then if you were to think of the entire systems integration with any of these things, it's an enormous capital expenditure to consider and undergo. So I think making it easy and opening up access so people can actually do their own testing and measurement will be huge to move everyone further much faster than we are now.
Great. And then, Will, since you're at one of the leading quantum computing companies doing superconducting as a technology, isn't time to market important? I mean,
absolutely, time to market is huge here. And if you're going to be introducing, new components here, you have to be considering that the pace at which we're expanding how many qubits we're putting into our system is growing quickly. So any type of cryo RF setup that's considering how many signals that you're working with inside a fridge always has to have your eye on what's going to be the next generation. How many qubits are they planning for next on their roadmap, whether it's us or any other big QPU provider. So to think that you would want to maintain all of the test and measure infrastructure in-house as well as make all your components yourself, it just seems like a Herculean task to take on.
Yeah, great. Jens, do you want to take a shot at this question as well?
Well, I think the key word here is time, because either you're at a university and want to have an idea and want to publish something, or you are developing a product. You don't have time, even if you had the capital and you wanted to expand it. I mean, you certainly don't have the time, because working out all those little problems that you have, and the theory for a lot of products isn't too difficult when you look at it, but ironing out all those technical problems that really make it easy to use, that's often difficult. So this is why we say just use a finished product. Should we ship it the same day so you can really start working on it right now?
Yeah, great. Thank you, everyone. All right, let's go to the next question. So Jack, why should a customer consider using outside test services such as your test service?
Yeah, I think there's a couple big use cases that I like to think about. One is the thing that I talked about was just that there's this very high capital cost and really long lead times associated with any of this. So if you're a startup and you don't necessarily have access to a university collaborator or, time on an instrument in general, this is a way to kind of get some of those initial experiments done, figure out what are the most important things to your program. And then especially as you're starting to scale up, right? I mean, if you're going to start going and start testing wafers, you might not need full capacity on a system right away. So sometimes it's hard to make that initial justification for that high capital expenditure. So instead, you can kind of test around, play out some ideas, start to gather some data and understand what the important test regimes are. So I think it's kind of a stepping stone to think about what you do want to invest in and what's important for your program. And then also for other people, it just eliminates the barrier to entry. So really making things cheaper and much faster. Yep.
Great, thank you. Anybody else care to comment on this?
I have a question. Can I raise a question?
Sure, quickly, but I really wait for the end on that.
We are
if
a
it's
university.
relevant.
Yeah, we are a university center, and we are working on novel qubits, and don't want to go through the process of setting up extensive facilities to test them. So it'd be great to collaborate with you people. But could we actually work with you on a research contract? I mean, in other words, like when you put in a research proposal, Could we take you in as a partner?
Sure, I'll field that. I mean, I think in general, it's pretty clear that the industry is still kind of bridging, industry concerns versus academia concerns, and we're more than willing to engage with all types of people in this, right? So certainly we're interested in development and supporting that type of work. So I'd be happy to take that offline and we can have a discussion around it.
Okay, thank you.
Yeah.
Great, thank you. Any of the other presenters want to comment on this?
I have one that I'd like to bring up. I mean, one huge thing here is just the standardization and the fact that outside test services are going to have a fixed configuration over time that's proven out. So a lot of the innards of anyone's fridge is changing over time, especially in shared user facilities. So a one-to-one comparison that your components are in this fixed configuration is a huge vote of confidence when systems integrators are looking at which components we would like to pick off the shelf to put in our systems.
Great. Jens?
Oh, I think it's fine.
Yeah. I can add a quick comment on this. So when it comes to something to build on Will's comment about having something that's reliable and tested, one trend within quantum computing, in particular in superconducting qubits, it builds a lot of confidence to test certain qubits at, for instance, the same facility, if that would be the same, but coming from different clean rooms. So that's one way to test and benchmark if a problem is with the qubits or if it has to do with the system, because that's often a big problem for individual universities and companies to distinguish between those two.
Great, thank you. Jens?
No, we're not really offering test services, so I can tell you from the perspective of a user who sends his devices out for testing, but
That's fine. Yeah, if you had a comment, I just wanted to give you a shot. So one more question for Jack that came up in the chat. Let's not spend too much time on it, but one of the questions is, is FormFactor also looking at test services for photonics at cold temperatures? Because that, with transduction and future things coming with quantum computing, is that something you're considering now or later?
Yeah, I think, FormFactor has a really nice wafer prober solution for room temperature stuff. And we're very interested in scaling that up or scaling up photonic probing to the wafer scale at cryogenic temperature. So we have chip scale solutions now, and obviously the demands of a photonic chip are a little bit different, where you have to think a lot about the degrees of freedom. You really have to reduce vibration, and with the trends toward closed cycle systems, getting rid of liquid helium, you have to be really careful about vibration. So that's something we're well aware of, and we have chip scale systems designed for it, and like I said, we're developing wafer scale solutions for it. So
Great, thank you. Okay, so not to put you on the spot here, Jack, but one of the concepts that you and I have talked about, and I've talked with others about, is how can we enable advanced room temperature testing for various superconducting components so that not everything has to be tested in a dilution refrigerator? You want to start there?
yeah, I think this is a really interesting question, right? So one of the biggest problems, again, is the high capital cost of cryogenic equipment and getting started with that, right? So when you're investing your money in a deployment system like a dilution refrigerator, you want to spend your time deploying chips and spend less of your time, testing and doing some of the test and measurement development there. So one of the things that would be ideal is if you could measure your wafer or chip fully at room temperature and get all the diagnostic data you needed to, and that diagnostic data was perfect in informing what was going to happen at low temperature. So this kind of gets into the idea of, can you get a high volume of data at room temperature, and then can you predict how that chip is going to perform at millikelvin temperatures? And we're seeing a lot of the leading developers talk about this type of scenario. So you can get some preliminary stuff at room temperature, and then you need a high volume of data at low temperature, whether it's 4 Kelvin or 50 millikelvin. And the bridge there is really developing machine learning models, right? So you can input all this data, and eventually you're going to build up a model where you understand what's happening, or can better understand or better predict what's going to happen with that qubit chip at millikelvin temperature. So we kind of see the cryogenic wafer prober as one of the key components of this, in the sense that you can do the room temperature testing now, you've got a 4K cryogenic wafer prober, and then you have to start collecting the data at the millikelvin temperatures, right? So I think the machine learning models are going to require all those data input, and we see that the wafer prober is a key element of that.
Great. Will, do you want to add on this?
Yeah, sure. I mean, first of all, that was spot on for our concerns as a system integrator. So as we operate our fab and then look to translate the chips that we're fabricating into QPUs, the biggest thing is ensuring that when anything goes into our fridge, that we have as little uncertainty as possible based on the metrology that's available. So we have models and we do a fine job, but anything that's going to reduce that uncertainty further. So we know that at any given time, we're selecting the best device from any wafer of chips would be tremendous. I can't probably foot stomp that enough. So whether that's cryogenic wafer probing, or if someone has another idea for metrology that the field is not looking at right now, that could be more indicative to help build these models even further, we'd be all ears.
Great. Philip, you want to comment on this?
I think Jack and Will covered this pretty good. Obviously, the problem is with volume when it comes to low temperatures. How do you get those statistics up in a reliable way? It's quite easy to do this efficiently at room temperature, but once cryogenics is involved, it starts to introduce technical challenges. And this is something that we're at Keysight working on this as well, but not the cryogenic aspect of it, but when it comes to probing systems.
Great. Okay. So next question. So this is a topic I want to make sure the audience is aware of, right? But beyond next generation hardware, software, and test services, what other advantages, solutions do each of you offer customers, such as consulting? I'm going to go right back to you, Philip. You had mentioned that Keysight does this, but I don't know if customers are aware of it.
Yes. So what we like to think about when we engage with customers in quantum, things are so complex, and even though our customers are very knowledgeable about what they want to do and the technology around it, we do see a big need of industry stepping in as consultants in some sense to reduce time to market and to help researchers that they might have a knowledge gap in some aspect of the research, or they are just eager to get results faster. So we do a lot of consulting when it comes to cryogenic measurements and how to do calibrations efficiently, and even how to characterize devices efficiently. So there's a lot of aspects here, and I think this is only the beginning.
Great. And then Jack, you had shown in your test service chart that you actually work with the customers to define the tests, and you bring a lot of your team brings a lot of expertise to the equation. Can you expand on that?
Yeah, so building a little bit off of what Philip said, I think we've identified some of the things around RF component characterization and performing RF measurements at cryogenic temperature is really important. So we've certainly leveraged a lot of the information from Keysight in that realm. The other thing, though, that I would say that we're noticing is sometimes it's not always clear what things you want to measure yet. So I think it's being approached on a number of different angles, and our team is really kind of built up around trying to understand those various test and measurement scenarios, and then trying to help customers think about things that they may not have thought about before. Is this particular measurement, like if I'm going to do an S21 or something on a new resonator material or something, how does that properly inform what's going to happen at low temperature? So a lot of it is guiding some thinking around what are the important things to do at low temperature, and then obviously setting up the measurements and supporting the actual the physical, let's set this thing up and make the measurement. So our team is really set up to do both of those things right now.
So, and then the benefit is the customer can get to time to market much faster, or through the research project much faster, right?
Yeah, exactly. I think, time to market is a big deal. And then really just honing the whole test and measurement and development routine. How do you speed up that development cycle so that you can get to market faster?
Right, great. Will, you want to comment on this? Does this touch in your area?
Yeah, I mean, the other big thing, like on the fab services side of things, is we're also offering not just these standard chips, but of course, you can submit designs and sign up for a subscription with our foundry through the Rigetti Foundry Services MSA. We allow you to design your own topologies, qubits, whatever kind of device you would like to design. Like, feel free to drop us a line and we can start discussion and see if it would line up within our fab processes. And we'd love to fabricate things for you. Of course, Rigetti also offers, full-scale quantum computers on the cloud if people want to learn more about quantum computing, but that doesn't really pertain to this hardware discussion here.
Yeah, great, thank you. And then, I know that we had this in a prior webinar, but maybe just 30 seconds, you just touched on it. So Rigetti does provide full fab service to basically anyone, right? For superconducting components?
Sure, that's correct. So we've locked in a few of our fab processes that we offer to anyone. So you can submit your arbitrary designs, and then we will run them through our fab processes that we have opened up capacity on with Rigetti Foundry Services. So we are quite touchy about the process, recipe, metal stack, those sorts of things, but we're happy to take pretty much arbitrary topologies and run them through our fab and then send you devices.
Great, thank you. Jens, do you want to comment on Thorlabs' approach? Say, for example, if someone buys, this, if you end up offering the whole single photon detection test kit, do you provide expertise in setting it up?
Well, sure. So first of all, in terms of general advantages, even if it's dangerous repeating myself, so I think the same-day shipment is something that is really an advantage, where we invest a lot of capital to keep everything in stock. And we do have very low friction tech support. So even beyond our manuals and what we offer on the web page, all the technical details, we're pretty proud to have people in our tech support with very deep technical backgrounds. We're also very happy to work on OEM projects. For example, for Thorlabs, is always the first question isn't is it worth the money in that sense. So we're not starting out with a calculation how much money are going to get in. So we always look at OEM projects as something that we can benefit from because we're learning about the needs of customers. Now, to your more direct question about the particular kit, yeah, we're always looking to help out people, certainly. I mean, this is if someone has a problem setting these up or expanding on it, we're certainly there to help.
Great. So let me go to some of the other questions that came up. Is there a standards development organization, not just NIST? Has anybody got any comments on that? Hello?
Well, in Germany, there's the PTB, which is pretty well known in the community. It also does a lot of quantum, where, for example, you can also send your detectors for calibration.
Who is that again?
The PTB in Germany, which is basically the NIST equivalent in Germany.
Oh, wow. Great. I didn't know that. Great. Okay. Anybody else want to comment on that?
No, I think NIST is still kind of leading the way there. I'm not sure what else to contribute. So.
Yeah, we have some NIST folks on the call, and they could speak for a whole hour on the topic, but there are standards metrology institutes worldwide. There's also a lot of coordination, in particular on single photon sources and detectors. That's a very strongly connected community.
Yeah, okay, great, thank you. Any other questions? Okay, so I think we call that a wrap. We can talk about our webinar schedule and prior webinars. So we are actually looking next to do a fairly curious topic on quantum computing, and we're calling it untangling quantum computing. We're going to focus on, you know, how are companies using consulting services today to get to quantum advantage next year. So we're looking to have various leading consulting agencies give presentations there, and then we're going to start into a series of you know, around quantum computing and software for quantum computing after that. And we're actually in the process of planning out the rest of the year. Celia, any last words?
No, thank you, Mark.
Great.
And thanks to all the presenters today.
Yeah, thank you to everyone who presented today. Again, you know, we can just look at the list here. So we had Jens Kuchenmeister from Thorlabs, Jack DeGrave from FormFactor, Philip Krantz from Keysight, and Will Madsen from Rigetti. Thank you all.